Okay, does that looks okay for everyone? Okay, we're gonna wait a little while to make sure other zombies wander in, right? So today is going to be sort of like a grab bag of sort of trying to get a good handle on some core ideas. I initially was banging my head thinking about how to have like good slides or whatever. The answer is anything you guys want me to have good little cheat sheets of afterwards, I will hack out and have available by tomorrow morning. Okay? Because there's so many different pieces of like all the thinking that goes into how do you actually want to model and build interesting state or protocol anything that like it's hard to really know what people are going to need help really grasping. Does that make sense? Also, I'm here all week, so if people find some of the bits and pieces interesting, I'm here all week and I'll be hacking on sort of more fleshed out fancy stuff. Because it's also literally my job. Are we expecting anyone else, do you think? Or what's everyone's guess?
No.
Okay, yes. You have the right idea. I don't know your name yet. No. Him.
I'm Christoph.
Christoph. Where are you from, Christoph?
I'm from Belgium.
Cool. Where are you currently?
In Belgium.
Cool. How is Belgium this time of year?
Well, it's an atypical year, but it's actually very nice weather for the moment.
Oh, that's cool. Yeah, I've been joking that New York City has the weather the West Coast wishes it had. Like, the winters are mild right now and, you know, stuff like that. I'm going to put my chair on this side so I can sort of look at everyone and see how illegible the screen is at the same time. So I'm going to wait a little bit more until, where did I put my water polo? It's still over there. So, do you think there's anyone else still coming, or what does anyone have any estimates on that?
Couple minutes.
We should wait for stragglers, yeah. So I think I'll sit this way so I can actually see whether the contrast is poor. And
I mean, we can turn off some lights.
Lower it slight. Oh, that a little bit of light, but yeah, we can do a teeny bit more light, maybe. Oh, it's you.
On me. Okay, so I think this is the light setting.
Well, if we need more contrast, people will yell and push buttons. I think having light helps with being awake, probably.
Yeah, definitely.
So what am I? So where's people from again? So like in terms of jet lag, am I the most jet lagged person in the room or not?
I think you.
Oh yeah, Chicago.
India.
Oh, how? But that's only 3 hours different.
Yeah. Where about you?
Manhattan. That's 6 hours different. It's a competition.
I'm at 0.
Which one?
It was 0 hours.
Okay.
From Netherlands.
Time zone wise. Cool. Okay, so.
Was there a German? Was there a German?
Wie heißt du? That's all I remember from German class. I dropped it very fast. Is this good? This is a legible size?
Yeah, the size is a little bigger.
Okay, I'll adjust the theme just for you guys. I'm thinking white text on black background is probably good, or what do you think?
Let's try. Solarized is usually okay.
Whoa, more bodies.
Question?
Yes?
How much dependent type stuff is
You don't really need dependent types to get stuff out of it, and honestly, as long as you know how variables work, don't sweat it.
Okay.
Let me just. I mean, the ideas are there are some dependent things that come up, and if you're stuck afterwards, I'm happy to help you hit your head against the wall with it.
Okay.
So I wouldn't sweat that because honestly, it's an important thing at certain level. Let's see. Is this a good contrast?
No, the last one was better.
Really? You guys just have. I just disagree. I'm going to disagree, but I'll respect your needs and do that. So yeah, dependent types. Don't worry about it.
Okay.
Because today it's going to be really about a bunch of. Are you comfortable with like gadgets and shit?
Yeah.
Okay, then you're fine. Because honestly, the way dependency becomes a useful concept is it shouldn't block the core understanding of things. No, that's wrong. I'm sorry, guys. I'm slow at theme clicking, color scheme clicking. So it was solarized was good, or what about notebook? Is this good or terrible? I don't know. We'll go back to solarized.
It's more the light. I think you can take whatever color scheme you like if the light would be.
Going to be that one.
So we'll do solarized light for now. So this will be good. I have lots of text editors open. Wow. Just so we're shutting off. My ability to prioritize knows no lower bound or upper bound. I forget which one's worse. I'm going to find the bathroom in a few moments and then I'll be back. But what I want to sort of cover today is first sort of have like a conversation with you all about what the heck is blockchain, or what's that a proxy for, and what problems are people trying to solve with that. And then let's just actually talk about bits and pieces of the ideas and techniques and logical methods that actually can give you potentially like a nice programming environment, or for sort of describing protocols, ownership, and all that jazz. And so maybe a little bit about how to fake co-inductive programming in Haskell, which is actually exactly equivalent to semantically what co-induction actually is in tools like Agda. Sort of a little bit about like what is linear logic, and a few other bits and pieces, and hopefully some non-trivial examples. And whatever I don't cover well today, ask me, and I'll make sure I have that as part of the fleshed out stuff tomorrow. Does this sound acceptable to everyone? Mm-hmm. So view it as more of a sort of a workshop tutorial on here's a synthesis of a lot of old and new ideas and sort of how they kind of fit together. And my perspective is that you should feel like you came away with a better way of talking about certain ideas, or how to think about them programmatically. And in tandem with that, what else? A little bit more comfort in terms of delving into any of those areas deeper, and sort of how you might go about implementing them. Now, I'm going to do a bathroom break first. Does anyone know where the bathroom is?
It's over there.
Okay.
Right in this.
So, okay, so a little bit about me. For the past 2 years, I've been sort of some applied R&D efforts at JP Morgan, a lot of which have centered around, I don't know, blockchain. Does anyone know what that is? Or like, well, okay, everyone knows it's like that Bitcoin thing, right? But why are businesses interested? It's not because banks don't want to be banks. Like, what is it a proxy for? I don't know. Who's comfortable trying to catch a water bottle right now? Are you comfortable? Okay, go on. Oh shit. Are you sure? I'm sorry. Do you need a hug? Okay, thank you for giving back.
This is more. I have
I should. Next time I'll use a hat or a phone.
A close bar.
I have a Rubik's Cube that can be passed around if you need.
Okay, someone. Okay, can I have my hat back, please? Cool. How's that different from a library book?
From what? A library hack?
Look, I don't know. When you take someone else's book for a little while and then they get it back. Someone, anyone, I don't care. Interrupt me. What do you think? How's like lending someone a book or a water bottle different?
You were worried that the library might find you?
You
Okay.
can consume the water bottle. You cannot.
Okay,
consume
but
the book.
only if they say yes, you can sip my water bottle, right? So okay, so that's actually interesting. So water bottle has like a resource involved that is ephemeral, like it might evaporate, or I don't know. Water tastes gross when it's not aerated, right? So it might be gross tasting later. You might be concerned about BPAs and be like, is it all natural or not? Or like lending someone a phone. Okay, here's my phone. You can take a picture with it if you want, because that's, or dial 911. But you probably can't text my girlfriend or something. Also, she'll be upset that I mentioned her, even indirectly, because she's shy. She has her calls this week, so it's a good week to not be around because she just wants to study. But so, how, like a phone? Okay, let's talk about someone else's smartphone versus a library book. How are they different? Because we already talked about that there's like a ephemerality or notion of time constraining the value. It'd be like a monad of time access, maybe, or of resource consumption for a water bottle. How would a library, like, so there's you get a fine, but you know, what if it's your friend's personal library? He might just be really pissed at you if you don't give the book back, or if you don't return the phone, right? Okay, does someone have a favorite database here? There's no wrong answer, literally none. Okay, I've heard good things about it. One of my favorite party tricks when I'm trying to help people be more comfortable being computer people is, let's go to a random file in the Postgres source tree and figure out what the fuck it does. It's a good party trick for like helping people be more comfortable with like jumping into a new code base, right? Let's just choose a random file. I don't do that for MySQL though, but partly because C++ is really complicated. But so how would you so what if I said I want to model library books, and you can't hide the database behind a single API server? Several different applications should be able to write SQL queries or whatever to that. Does it start to get a little tricky? People cannot what?
Why is it different from the usual database?
Well, usually with library books, you can't clone a physical copy.
Okay.
SQL doesn't really enforce that, right?
Okay.
Like, okay, you could do some tricky things with like unique key columns, but like, I don't know, some people here probably do a lot more SQL than I do. That gets really fragile fast, right? Like having unique key columns, and then like, well, I need to evolve the schema because now you can rent a Netflix, now you can borrow a Netflix or ebook account, or like, we have to add a separate thing for the rare books collection, or, you know, or some sort of software you can borrow. Some people are nodding smaller. They can say yes. You're nodding a lot. Are you under, is it because you're like, yes, I know what you're talking about?
Yes.
Okay, cool. What part of it are you seeing like, yes, this makes sense, or?
Well, I don't know what you are going to say, but I guess you are going to linearity
Yeah.
with the resources.
Yes, yes.
But,
So part of what the blockchain is a proxy for is we want databases and applications where by construction, whatever we build on top, only things that respect the rules of manipulating and handling those resources are valid. And you don't have to worry about, oh, that intern's application destroyed the .library database because now they have 3 different copies of the same book lent out and we don't know which one's the real one, right? That's never happened, but I just made up that example. And we all know interns make great SQL bugs or any other programming system. Welcome, you haven't missed much yet.
Yeah, thank you.
But yes, so linearity, but it's not just linearity, it's holding and owning. Whoop. Can I have it back, please? Thank you. Okay, but holding as owning as a useful concept. And it's not just for, like, I don't know, modeling like e-stickers and shit. It's like in databases, when it's really funny when database learning materials introduce transactions, they're like, let's use a bank as an example. There's a lot of interesting and really funny ways that doesn't actually map to how accounts work in banks. But there's a really good example of how it blatantly doesn't. So with SQL tables and rows, you usually only have like account-based read and write permissions, right? How can I give you money if you don't want me to have a write permission on your account? Or possibly even a read permission? That kind of is a data modeling mismatch. There's no notion of being able to give information from one account to another, but that's how money works, right? Everyone agrees with that, right?
Yes.
I mean, you don't, on the flip side, I probably need permission to give you my debt, which is another type of like resource, right? Everyone sort of following this and being like, okay, this is like a good motivation, but you know, when do we get to the math and the computing? There's a separate thing that also goes on when people talk about blockchain in a sort of applied business context. Okay, who's someone whose name I remember? Leon.
Yes.
Let's do a collaborative project together,
Okay.
but we'll have to like keep track of things, like who emailed whom, because someone will flip their shit if they get emailed twice, because they got enough emails already last week because of GDPR, right? I don't know. So I'm sure some people have a GDPR email filter by now. But, you know, there's things where, like, you actually want to have strongly consistent information, but there's more than one owner or administrator of a project. Like, how do interbank wire transfers work? Let's ignore how they actually work for now because I'm actually involved in a team that's fixing that. But the point is you actually want there to be a notion of synchronous coordination between multiple organizations, and then you also have sort of this idea where you want to also model the ownership structure correctly. Okay? And, okay, so that when's the first break at? Like 10:50 or?
Yeah.
Okay, cool. So when people say blockchain, me and colleagues on my team are really like, how do we, and it's not that everything we build is this way, but in terms of how we want to think and the software systems we want to have, we want to be able to actually have holding as owning as sort of like the core modeling primitive when you're actually defining and working with a resource so that you could do the library books example, because nothing under the blockchain umbrella today is anything you'd be comfortable making your life easier for building a library book database that has an open read-write query sort of experience. And separately, how do you coordinate things when there's more than one owner? That veers very much into authorization and synchronization and distributed protocols and all that jazz. It's getting warmer in here. It must be all the bodies. Everyone can hear me, right?
Yes.
Excellent. So we're not really going to get into distributed systems, except maybe as examples of non-trivial stateful protocols. But what we might talk, let's actually review some really boring stuff. People here know logic, right? No?
Sponsors.
Okay. Is that acceptable?
A bit more. Yeah. Or turn off the lights. Yeah.
Yeah, okay, we'll turn off. I'm going to push the button wrong, but we'll figure it out. Okay.
Thank you.
So I actually have the first half of a cheat sheet that looks pretty, so I'll actually pull that up. I thought I had it up. Where? Oh, it's because I restarted my computer. So classical logic, everyone knows that. You have double negation elimination, right? You have this sort of distributivity of negation under and or, right? You also have sort of a similar generalized thing for all and exists. And then you can actually go further and you can have contrapositive. Now, this is kind of an interesting one, and I'd like to point it out. And I don't mean to imply that I have a perfect answer to this, but for those of you here who are, so a lot of these are sort of, they can be made constructive, but they aren't necessarily constructive as ways of sort of relating statements as people are comfortable with, or used to them, right?
So why are they not dualities yet?
Can you say that again?
Why are they not dualities yet, according to that document?
I'm sorry, what? They aren't constructive?
It says they are not dualities yet.
Okay. Oh, you're going to find out. So a well, I mean, they kind of are dualities, but they're not interesting dualities. Because for technical reasons, you can't actually, it gets, so this is an important point. This is not, don't interpret, and there's room for me to not be perfectly rigorous. Because this is me trying to also cover a lot of ideas. And like one thing we're going to talk about shortly is continuation passing style, which I suspect a third or a half of the people in the room are comfortable with, like you.
I'm comfortable with CPS.
Cool. We're also going to talk about linear logic. And I actually, so actually there was I had a pretty comfortable model of linear logic in my head up until pretty recently, but a recent paper helped me really figure out how to think about it even more precisely. And actually, I'm going to start with that, and then I'm going to backtrack to CPS, because continuation passing style gives you a way of embedding negation in constructive logic, and embedding classical logic in constructive logic. But linear logic actually, there's a really nice way of understanding what the formulas might mean that you can get without using, so for those who are wondering what paper helped me figure out a nice exposition, there's one by Mike Schonwald. I might not be spelling his name correctly. He has a recent paper about linear logic. A lot of it is sort of orthogonal to sort of what I'm hoping to discuss, but it covers some really cool ideas and it sort of helps give some nice model examples motivated by like foundational math. So let's talk about proofs and refutations. So a proof is saying A is true, whereas a refutation is saying not A is true. Now, again, this is a simplification for purposes. They can have a very precise meaning. Also, if anyone wants, I can make anything I type available later. But if typing helps you, great. So let's talk about A and B. Let's say we're ignoring quantifiers, we're ignoring anything else. What is a proof of A and B? That's equivalent to, we have a pair, proof A, proof B, right? This is very boring. If you're comfortable with Haskell, that's literally just tuples, right? Now, how do you refute a B? So that would be a proof of not A and B. Right? This sounds reasonable. But so if we go back to the sort of classical dualities, that turns into not A or not B. But actually, let's start with or, because that's a better example from a linear logic perspective. Pedagogy is really tricky. So when we prove A or B, we can just give you an A or a B. That's sometimes either, right? How do I disprove that? Well, if I want to disprove that, I need to be prepared to show both. Well, I don't really want to give you both a proof of not A and a proof of not B. I want to be able to respond with whatever proof you gave me, a specific proof of falseness. And this is sort of where things get linear. Why would I want to do a redundant proof? I don't... I want to be able to choose whichever one is appropriate. This is slightly so. Let's flip it. So here's a good way of actually making that digestible. I want a case either A, B, right? I can do left A, proof not A, am I using both proofs? Or do I, when the constructive interpretation of my sum runs, are both are, yes?
Can we ask questions?
Yes, I want you to ask questions.
I'm super confused.
Okay,
So,
that's great. Help me.
A proof of A or B, and so what you are saying is that you can either give a proof of not A or a proof of not B. That sounds very counterintuitive, because if you only give a proof of not
So,
B...
okay, so you tell me which one. Think of it as, imagine you feed it, imagine this is a imagine this, I have the right-hand side as a function. I give it a left tag, it outputs one thing. I give it a right tag, it outputs the other proof. But, think about...
Wait, what are we proving? Are we proving...
we want to refute A and B.
Not A or B.
We want to refute A or B, which means we have to provide a not A or a not B. But we don't know which one until we see... We want to provide either one on request. That's the right hand... Well, how?
So I'm confused. So
No, this is
I'm
good.
saying something wrong, but if you just have a proof of not A, it could still be that there is a proof of B, right?
Exactly. So so maybe I want to derive a contradiction. So I'm doing a case on this either expression here, right? I don't know until you give me the left tag that I need a proof of not A.
So where does the either come from?
I just have an either. I have I have some statement that is a type either A, B. I mean, so maybe let's
But
so
if you have either A, B, you have a proof of A or B.
unless you're deriving a contradiction.
Ah, so it's an assumption.
Yes.
Okay.
And so what is the type of the right-hand side here? We want this to be sort of a let's just consider we actually want to drive a contradiction, so we get bottom somewhere, right? So proof of not A is going to be, not A, which is going to be equivalent to A arrow bottom or void or whatever, right? So what we want is a choice. It's a sum type. It's a pair of proofs, but I only can give you one. What is the type of the right-hand side of a case expression? No, that's of a particular branch. I guess what I'm saying is, so usually when we do not A or B, we get A, not A, and not B, right? But I only need one of these to derive the contradiction. When I evaluate a case expression, only one branch is run. I'm trying to sort of fill out the duality here. So we know it acts like a pair, but we only need one side, and we need to know how to provide either side of this and-like thing. But it sort of is a reactive thing where I sort of say, I can provide either one, but you have to tell me which one you want.
So is what we are doing, we are making the assumption, just assume that we have an A or B, and then if we assume this, we have two choices.
Yes.
We could have a...
Choices is exactly the right word. So let me actually, let's rewrite this right-hand side. Let's forget the case expression for a moment now. What we want is not A or B to be equivalent to a choice of so it's kind of like a record, but where we only use the record once. Because we're sort of trying to figure out how do we get to linear logic. So imagine that we have a choice protocol. You tell me which thing you want a refutation of, and I will give it to you. So let's assume that we have, okay, when people in a functional programming setting usually talk about linear types, they're saying a variable or value can be used exactly once. If I give you a record where I can only choose one field, that usually sounds a little bit weird and broken. But sometimes a record isn't, so maybe a better way of putting it is, in object-oriented programming, when you invoke a method, is the object the same one it was before you invoked the method changing the state? Or is it more like it kind of replaced itself with a new object that happens to have the same data fields?
former.
Well, okay, you're thinking in terms of reference equality. What about in terms of value equality?
Also, in this case, it doesn't.
It becomes a new thing.
If it's a query, it doesn't.
Okay, but if it was a write,
Okay.
yeah. So anytime you do a method that is a object update, you could do a functional transformation
Sure.
that turns it into sort of like a state monad, state passing representation. And when you do linear logical programming, you wind up having the in-place update one still look like the state passing code. So we could view this as sort of an attempt to start to model that kind of object in a functional way. So this would, let's actually make this infix. So when I'm going to say choice a lot, and I can't spell, when you see ampersand, that's the choice operator.
Maybe you could ask people whether they know what the Curie-Howard isomorphism is.
Okay, do people know what that is?
Yeah.
Okay, people who don't know, sorry, I made very strong advanced class assumptions. Okay, so who here is uncomfortable with the word Curie-Howard? Okay, you're gonna, you
Is
guys,
it uncomfortable or comfortable?
uncomfortable. Like, okay, so for me, so this is actually a good, thank you for asking for them. Interrupt when you're confused. This is the most important thing because other people will be confused and they're just shyer than you. So the Curie-Howard isomorphism is this really simple, powerful idea, and there's some really good writing about it out there, but the idea is type systems are really the same as logics, and proofs in a logic are really the same thing as programs. Whether they're interesting programs or not is a separate issue. When we talk about the pair or product type, we're talking about logical formula that are ANDed together. When we talk about A or B, we're talking about either. We're saying one of these is true. And so part of what, and when we say A implies B, we're saying we have a function that takes a value of type A to a value of type B. And this is actually very powerfully, very effectively in computer-assisted or computer-checked theorem proving. You know, that, and that's its own entire area. And there's a lot of different tools that give different experiences for that. If you want to have a programming kind of experience for that, Agda is perhaps a good one to start with after you wait to get it installed. If you want to play with Agda later this week, I'm happy to help, but you should install it when plugged into an AC adapter. There's a new version now. I use a slightly older one, but as long as you don't care about one or two tiny things, it doesn't matter. But there are a lot of good ideas in terms of programming language design that sort of live first there, and a lot of other programming tools are sort of slowly adopting ideas from there. On the Haskell tooling side, one thing that is sort of on the lightweight end is Liquid Haskell, which lets you sort of add these sort of kind of logical formula specifications to your programs. Is this helpful, or are people still confused? The people who raise their hands, do they still want to raise their hands? Please let me know.
I'm confused about this transition from just logic to undefined in Haskell code.
Can you say that again?
The transition from the logic we have here on
To
Haskell code we just did.
So this is about what is a proof? A proof is a program. A logical formula is a type signature. It's really that literal. Now, Haskell itself, I can prove anything I want by throwing an exception. That's not a very interesting or useful proof. So when you're talking about proof development, I will be, by and large, using Haskell notation here, but assume that there's no infinite loops or things like that. If there's interest, I can sort of try and summarize some ways you can avoid having these issues later on, like maybe in the next session or sometime tomorrow. But the idea is, you know, the fact that you can throw exceptions is like an escape hatch to be able to say anything is true, just like Trump. Actually, fun story about Trump. I hope this gets edited out. Mihao, is he here still? No, he's not. So actually, when me and my two younger sisters were in like K through 4 in the U.S., the only middle schooler on the bus was Eric Trump. He was a dick. So actually, fall 2016, when people were like, how are you voting? I was like, I'm not voting for the parent of the school bus bully. He was a dick. But actually, my younger sister, when she was in kindergarten, has this recollection of a very great quotable, and her like 5-year-old interpretation of it as an even dumber sounding thing. So apparently, Eric Trump was like, when I'm older, my dad's gonna give me a mansion full of chicks. And my little sister was like, why would you want a house full of baby chickens? Which is so adorable. So with linear logic, okay. Let's just briefly have some examples of linear logic. Now, when we're actually programming, sometimes you want to use variables more than once, or sometimes not at all. Sometimes you want to make choices. Hopefully they're good choices, like making fun of Trump. I assume everyone's cool with that, right? I actually, on the flight over, there was this Polish dude who's working in the US who was like, Trump's great, Hillary's a liar. I'm like, what? And I was like, very nice guy, considering he was a total idiot and wrong. But, you know, so what's a nonlinear example? So lambda x to x arrow x is bad. Also, it generally looks, that's kind of like the call by name fixed point operator, sort of. Or I could do, actually, let's just have it be plus. That is still bad from a linear logical perspective, if x is itself a linear variable.
So what is this plus here?
Repeat.
What is the plus here?
Plus, I want to add two numbers.
Okay. What if x is not a number?
Well, then this is going to not type check.
Okay.
You can assume that plus is a trend and this is something.
Yes, we could have it make it be like num a.
So is this still nonlinear?
Well, yeah, because it's using. So let's actually. So we're going to say that this. Let's actually add subscripts. Okay.
Okay. But you could go like let y equal to x with, and then say y plus y.
No, because I already used. Okay, so that's actually a good question. So if I do let x 1.
So 1 means use only one's multiplicity.
Yes.
Okay.
I dislike a lot of. There's a lot of good ideas in some of the add multiplicity to type variable things. I also think a lot of the approaches are subtly wrong, and I juggle enough stuff that I still need to write up my view on this more. And so part of the point of what I hope to get out for myself with this workshop is to get better feedback about what is clear expositionally or not. So everyone feel comfortable, as these folks already are, saying, I don't know what the heck you're talking about. So this one's also bad, because I use the x here, so I can't use it here. I mean, depending on the order you type check the expression, right? Does this make sense?
Okay.
Any objections from anyone, or is everyone comfortable with that? It's boring and obvious, great? Right? So, in some sense, being able to duplicate things is bad, at least in strict linear logic, but you also can have like lambda x, y, X. Forgetting things is bad, at least when they're linear, right?
So why is that?
Because linear logic is things come from a source and they're used exactly once. What I actually care about is in general, is a logic where you can have variables used more than once or less than once, and also have, for the purposes of supporting dependent types and interested in modeling, variables that can appear in both irrelevant positions, where when you run the program, it's not that expression doesn't actually exist anymore because it's part of a type, and also, I'm actually using it somewhere. A good example of that might be, no, I'm going to wait to get to that later. So when I want to talk about disproving A or B, I want to have sort of that to provide that proof, I want not a, and then I'm using this ampersand character. Okay? Now, maybe this would make more sense if we start, yes?
Can you think of some, would it be useful to think of some examples for A and B?
You're 7 feet tall or 11 feet tall.
Okay.
Are either of them true? If you claim one of them, I only have to refute one of them. But if you claim or of this, I need to be able to provide either proof. And in a linear setting, I only know I have to refute one. I just don't know which one I will have to refute yet. So actually, as I'm walking through this, I'm realizing maybe we should first go back and explain CPS a little bit, because it'll make talking about these a little bit easier, perhaps. You're making a face. Do you agree or disagree?
I have no clue how CPS is going to be involved in this.
Okay, so good. So let's go back. Oh, it's good. I wrote CPS first. So when I say not, so what is false? In Haskell, a very good definition is void. We can also just call it data empty. It's an empty sum type. There are no cases, therefore you can never construct it. You've all seen some flavor of this because you're advanced Haskellers. Has anyone not seen this? Are you moving your hand or just scratching? Okay. No, scratching is totally natural. I support it. I do it all the time. Is everyone in? Okay, so meta point. Is everyone in? I'm doing a little bit of zigzagging to sort of calibrate here, but am I going at an appropriate pace for making sure you're trying to engage and sort of get confused? Okay, so we have the empty type. When I write not, so I could just do type not A equals A arrow empty. That is the constructive way you represent negation. That is, if I can write a value of type A arrow empty only when A can't exist, where A is some logical formula.
Void and empty is the names that you made up?
Yes.
Or is it
well, actually, you'll see.
Representation of bottom, right?
No, bottom in Haskell is slightly different because it's the value that is an exception. Now.
Okay, but it's a unit type that doesn't have that.
No, well, okay, it's the unit of sums, whereas unit. So actually, this actually gives a good point. When we talk about, we have sum and products, right? We usually talk for products. We have this. We don't really have this, but that doesn't. But we do have. Hello.
Hey, it's break time.
Oh, it is. Wow.
Already?
10 minutes break. Unless
Cool.
you're in the middle of something. I mean, you
Well,
are.
I'm explaining products, and well.
So finish your thought and we'll have a cigarette.
And then we have sums which, you know, don't really have a first-class syntax.
What do you mean this is missing in Haskell?
That's just a parentheses in Haskell. Now, for unbox tuples, you can actually write all of those. You can do this. You can do it's just there. People don't usually need it, although it's a nice. It adds a nice symmetry to have all of them, and so forth. So what we might actually want to do is have our product type actually just be a prefix then a list for when we talk about it. So then we just have product as just so that we can think of things more uniformly. I'm sorry that this looks like Scala or something for those who have too much Scala. That is not the point. The point is I wanted a list. I mean, so I think you're starting to see that this is for products. Well, we don't really talk about sums. We just say data either A, B equals left A or right B. But this could also just be sum A comma B. And actually in Haskell we now have an unbox sum type. So we could do that too. I'll show it to you, but you guys should all take a break and stretch and pee.
Thanks. So we'll start on the hour.
Just make sure also it's synced up, I guess. Okay, so we have products. So actually there's unbox products types in Haskell. Those are useful. And actually I might be touching on those later. There's also unbox sums. So we have either. So actually, but what we could do, so they recently introduced unbox sums to Haskell. So the unit looks kind of the same, but then you can do B. I'm not actually going to use this syntax, but let's see. Like this, these are okay, and you can actually play with them in recent GHC. I think they're slowly getting unbuggy. You can do some cool tricks with them. We're not going to talk about that all, but if people want to play with them later this week, I'm happy to help them get unconfused. So actually, what the notation I'll do here is like, we'll do times, unit. We're going to use LaTeX, because then let's not do the slash, because that confuses things right now, right? And I'll sometimes, for ambiguity, to help with the ambiguity, do either X or star for that, right? I'm not guaranteeing I'll be consistent. I'll try and be, but just so you're prepared. Now so this will be sum. We have the empty sum. There's nothing there. We don't really have syntax for the empty sum, unbox sum. So let's ignore that for now. We have the empty sum, either A, B. It's going to be sort of equivalent to sum A comma B. When we case on that, we'll have like first, second, third position. And in this parallel universe, we could hypothetically say that void is just a named version of the empty sum. And so what are the rules for matching on an empty sum? So how do we case on them? This is going to be really boring for people, but let's just write it down because some people might benefit from this, right? So I can do case X of type sum Well, so let's just do sum A, B, C. We just do case 1, C1A goes to something. C2A is going to be some variable of type B. We're doing puns here, and in Haskell, with Haskell syntax, let's just add a V at the end because let's not separate the namespaces. Even though in Haskell they are, it adds more complication for discussion later. So, and then we'll have like C3, case 3, which is going to be the third slot. Hello, Ava.
I'm looking for Lawrence.
Who?
Lawrence. He's not
I
here.
don't know.
I lost him.
Okay, so this looks like a reasonable thing.
What is C1 until C3?
Oh, like the projectors. Like which tag are we at? So we don't really have a syntax in Haskell for saying which part of an anonymous sum we're in.
Ah, yeah, I see what you mean. Like in left or in
Yeah,
right.
but that's only the binary one. And I will claim it's useful, even though it's confusing, to think of these as being an instance of a family of things that might have a 0 inhabitant, might have a boring 1 inhabitant. Like they all kind of look like sum and product in the one case kind of are the same, right? Isn't that weird? That's, I mean, it's cool. It's strange. Why are they the same? Their units are totally different. One is we can always manufacture the empty paren unit, the like nullary constructor. Where did I find this Twitter? Oh, someone followed me on Twitter. So when we're matching on a sum, we have these choices of things, right? And if we were in the linear logical case, we might have variables that we can use, and those are each available in each of these cases. But we can only use them in one of those. So these are how do we describe this sort of set of cases or collections where only one of them will be used? But we don't know until we see we dispatch on X which one it'll be. Do people understand that? It's a little bit subtle. So let's go back up to here, right? So we have this vocabulary. We have this. We have not. Now, classical logic says not A equals A. But definitionally, if we expand out this type, we have not A equals. So actually, let's actually add tilde to part of our notation, just because we're going to be typing not a lot. Okay. Now I'll just do neg as neg. Just because I already have a lot of notes that use that for latex, so I don't want to confuse myself. So not A is going to be equal to not A arrow void. If we start translating it. When we start translating it some more, we're going to have A to void to void. Does anyone want to sort of talk about how to think about this, or what do you think this looks like? Because you're just sitting near me, so of course I'm going to pick on you. If you were just describing this in normal functional programming? It's a function that takes a thing and returns a thing. Okay. Now, anyone else want to sort of ask or try and poke at this a little bit?
Actually, that's a higher order function, right?
Oh yeah, absolutely.
It's a functional.
Yeah, it's a function that takes a function and returns the impossible. That sounds like a Doctor Who episode. Or clickbait.
So if type A is inhabited, you can run the first function and actually get reward.
Yeah. You're asking the point. So let's reconcile that for a moment with this. In classical logic, or in truth table land, or if expression land, not of a Boolean value, is the original Boolean value, right? This looks like an exception. Like there's something exceptional happening here. So I'm introducing this to motivate continuation passing style. And then we're going to go back to talk about those operators. So when we want to do the double negation translate, so we want to have a way of talking about we want to make double negation make sense. So if I start with an A and B.
So right now are this thing not A and A isomorphic or not?
They should be. We're trying to fix that. Okay. There's a hole in reality, and it won't go away until we understand it. We're like, how do we make this work in programming? So
right now we do not know if it is.
Well, we're gonna know. Well, we know it should. We just don't know how.
Okay.
So if I have in normal Haskell land, let's just write this as a tuple so everyone's comfortable. This should be equivalent to not A comma B, right? Right? Anyone have, this should be true. What might this look like? Computation. So let's look at the previous line. So it looks like a computation. So it'll look like a computation that takes a where there's an A and B. So one interpretation of bottom is a calculation that never returns. Who here has heard of a tail call? Has anyone not heard of a tail call? Please raise your hand now. You didn't raise your hand, or?
Oh, I didn't hear the question from you.
Do you know what a tail call is?
Yeah.
Okay, good. So one interpretation of void is there was a tail call. So maybe what this is saying that this outer calculation is a prefix of a computation that knew how to manufacture an A and a B, and the rest, and it is given the next step in the computation.
Could you say that again?
Okay, do you know monads? I'm going to write a monad for you right now.
Okay.
So, monads and interlude. So how many people have ever written their own little interpreter? Great. If you haven't, be ashamed of yourselves and get better, because you'll learn a lot. So when we talk about monad, there's usually bind, which is this funny fishy looking guy. Let's just write it as you have an MA, and let's just write it the usual way. A to MB, right? You also have return, and let's use single semicolons because we're not actually writing Haskell and we don't care about lists. That's going to be an A to MA. We're ignoring for alls and stuff, and we're implicitly saying currying. There's also usually join, but how do I return?
Yeah, nice to meet you.
Hmm.
If you could
So what this, I guess what I'm trying to say is maybe this is like bind. So let's actually try and write this. So we have N and F, and we have, well, let's just pretend we have an extra argument. So we have double negation. We're given a arrow void. And we're given, well, that's what we're, actually, let's flip the arguments around. So we're going to give it an A arrow void. And we're given something that it expects an A arrow void. This looks reasonable. Like, who wants, so, So this is going to be what's the code going to be here? Given these types, it's really easy once you squint a little bit more.
And just apply.
Yeah. So now, but there's a related one. If you give me an A and what's this one going to be?
ABC.
What?
C.
Okay. Now, what's the difference between these two? So who here has heard of the term call by name or lazy? Okay, so what is lazy evaluation? Lazy evaluation is, it's actually the optimization of call by name. Every value is actually a calculation. It's just after the first time it's used, we scribble down the answer. So, interesting fact, if every variable is linear, call by name and lazy calculations agree, because each value is constructed exactly once and used exactly once. So we don't need to save the update anywhere. That is, but okay, so this kind of looks like return in a funny looking way, right?
The second one?
Yeah.
I'm not sure why.
I'm-
Monadic return, right?
Yes! You are so smart. Gucci, Gucci, goo.
So this is one direction of the isomorphism between not A and B.
Well, I'm showing you that
You were going
double
from-
negation,
You were going from
the
A
double
to not
negation encoding is a monad.
Okay.
Because
So
what?
this is return.
Yeah. So let's at least let's conjecture that. That sounds reasonable. Okay, so what happens then? So let's try and figure out bind.
I'm sorry, the second one was return. What was the first one?
I don't know. Let's figure it out.
Okay.
I mean, I can reconstruct it. I'm going to reconstruct it on the fly, possibly make mistakes, so that you guys pay attention.
How is void? Void is not an polymorphic type.
So actually, this gets into a very good point. Wait, so which part are you confused by?
Well, it's A to MA, right? And void is just void. It doesn't take
Well,
a
so
polymorphic variable.
Can you scroll down a little? You can see the. Yeah.
So
Yeah,
well, so I didn't
is
say.
an
So
MA.
important point. I have not necessarily written bind yet. I'm just trying to get us there. I'm just writing down some obvious things. So For call by value double negation, or CPS translation, this is the call by value return. This is the call by name return. That is, we're not actually guaranteeing that we compute A only once.
So, should you write data void A without constructor? Is that what you?
Yes.
So there should be an A.
No, there's no.
A is A to void to void.
Yes.
Ah, okay. And A is?
Yeah, so I haven't defined with monad. So data cont A should be something like, what did you say?
A to void to void.
Let's just do type so we can just expand it because we don't. So A, so it's parenthetical this way, right? And I'm being lazy about case because maybe I'm doing answer type polymorphism. So actually there's two ways of doing negation. If I have a value of type false, logically it means anything's possible because I proved true is equal to false or something like that, right? So there's both type false equal for all A, and type, I'm writing it as type because it's easier, right? But then we have data void, right? Either way, the moment you can prove something false, anything becomes possible. It's like, yes, you can be an astronaut too. Anything becomes possible, right? I'll use this pointer sometimes if people get confused. Don't worry, it's like under 5 milliwatts, so as long as you don't stare at it, you'll be fine. Okay, so now that we have this definition of this continuation, bind would be, what would be the type for bind? So we'd have A, void, void, arrow, A to B to void, void.
Isn't it a problem that A is in negative position?
Where is it? Which line is it? First, second, or third?
In cont M, for example, like we are building a monad for it, right? So.
Okay, so what? In which way do you? So it's in double negative position. You are right, it's in negative position, and that can be a problem for. You're thinking from like a logic methods kind of perspective. So we're kind of trying to figure out how to recover not A is equal to A here, right? So one approach is embed everything in the double negated form of the sentences and then work from there. So let's just write this type down again. So we have cont A arrow A cont B arrow cont B. So let's write that down now that we think we understand it. So what we might do is have bind. So we're going to take C comp. We have a computation for C. A to B, right? Those are our two arguments. So maybe what we can do is, well, let's think about this for a moment. What if we do C comp lambda A value arrow A to B A value? This is ignoring all the wrapping and unwrapping, right? Does this look like a like I'm defining bind correctly? Okay, cool. Now, there's two reasons that people do continuation passing style transformation. One, they care what order, when they're writing a compiler, do you care about the order of evaluation for your function arguments for a strict language?
Yes.
And you care about knowing when you have a value. So there's two main styles of compiler engineering. There's direct style and sort of continuation passing style. Both are very closely related to what is seen in a lot of more mainstream compilers, static single assignment. That is, when you calculate a value, give it a fresh variable name, right? And then you use that new variable. And this is actually an optimization. This also lets you sort of optimize away a lot of local variable updates by just saying, oh, it's a new variable, forget the old one. And you just say, just track when things are no longer reachable. The other reason you use continuation passing style is to embed or give negation a logical meaning. Now, I've written down the monad for continuations, but I didn't really say how are we translating code. So,
Could you explain why these type checks?
how about I write it in a file? Well, so which part are you concerned with?
What is happening here?
Okay, so let me, I'm gonna lie.
So A to B is like from A to N, right?
Hang on, give me a second. So what are we doing here? We have module live demos rock, and I'm going to define type cont a, so I'm going to do data false. I might do, let's just GHCI that. Oh, syntax errors.
You need a where.
Yep, syntax errors are the best. Oh, I didn't finish this. So Conte would be false. Okay, that loaded. So bind is going to have the type, what's the type? Cont A, arrow, cont B, arrow, cont B, right?
Yep.
Bind A comp, F comp, and I wrote A comp, lambda, A val, F comp, A val, right? Okay, it doesn't type, you're right. What am I doing wrong?
Could you show me error?
Hmm?
Could you show me error in the console?
Let's see. A, B arrow false to false with false. Okay, let's make this a data type.
So what is the type of this lambda?
Well, we're going to get better error messages very soon. Promise. Oh, okay. Okay, now I see what the error is. I can do it with the data. You'll see in a second. Stay tuned. Type, remove the constructor, and then we forgot the B continuation. And then we do, is this what I think this is?
You forgot an arrow after your first one.
Oh, yes, typographical errors are the worst. Okay, so what am I doing? So I'm feeding. Okay, so I need the B continuation to be an argument here, right? Okay, it worked. I just forgot to make a continuation of the continuation of the continuation. But, okay, so you're right, it was wrong.
Okay, but I still don't get this.
Okay. So you agree that this is the type of bind in mode. You agree that this has that type.
That is what I'm trying to figure out.
Can I make a very short suggestion? Maybe you can just take the add function and then show how to transform it into a CPS.
So add CPS. Okay, this is actually, thank you very much. So we have cont int. And actually, this would make a good use of bind. Good. So what we're going to do is we have. So we need to pass in where the calculation goes next, at the top, and then what we can do is x comp bind lambda x val. This is what happened before people invented do notation. So I hope you all feel very retro. Then we do then we do y comp bind y val, and then I guess this also looks like modern JavaScript, doesn't it? Right? Basically, they have the shittiest thing, so that's what they have to deal with. And then what we're going to do is, well, we can then just do
return x val plus 1.
pretty much. Well, we could do that, or we could do res con of x val plus y val. Let's see. Does that type check? Oh, did I forget one somewhere?
I'm missing bracket.
Yes.
Where am I?
Missing brackets at the end. That one.
And then
Lower.
Oh, parentheses. My other enemy, syntax errors, strikes again. What did I forget this time?
If you scroll down.
Oh, okay. So
You're not making void because you're not using real continuations. You need to give back false, which is impossible, right?
So what's the, let's see, the type of that.
But you're not really using real continuations, you're using the ones that return false, and so you're not giving back.
So what you're saying is I should do, if I change this to type, false equals for all A.
Maybe if you just make it int or integer.
Oh yeah, let's just do that. That sounds simpler. Thank you. So let's go back here. Are we on time?
You have 10, 15 minutes.
Okay, so we'll so data false, and then we do return. No, we can't because bind doesn't let us. So you're right. We have to do the answer type polymorphism. So type.
But if you just write type false equals integer.
Equals what?
Just integer.
And con.
You just make a type alias. Or int needs to be int.
So I think what we can do here is.
Well, bind returns a continuation, so you don't need lambda respond at the beginning, right?
Oh, you're right. Well, let's see what happens.
Then respond is undefined.
Here's our response.
This is why type checking is great.
And here you can bind respond.
I think you need to do a return at the end.
You don't have return though.
So we do lambda x arrow. Yes! So what we could have just done is C, and then we keep this false, and then everything works. Thank you. Now, this is, what we just did by hand is continuation peasant stuff. Now, what I want to go back to is, how do you do this? How do you do a CP? So we were doing we had some CPS of some expression to some new expression, right? So, let's talk about what the CPS translation of A arrow B would be. CPS type A arrow B. In this setting, that would look like, for call by value, it would be we get a pair of A and a not B, and it's a not B. And then we unpack that, and we get A, B, false. Does this make sense now that we struggled through things a little bit? A function takes two arguments. The value it expects and the continuation for the result of the calculation it does locally. Okay? Does this sound reasonable? Or confusing? Anyone confused? It's okay to be confused. There are people who spent their career doing CPS stuff.
Could you explain the expression for bind anyway?
Okay, so
not this one.
Okay, well, bind.
The one you wrote in has to.
Okay, so let's backtrack to that. So bind here is saying I have a calculation that yields a value, and I want to extract the value and feed it into the next step of the calculation. So bind is, the way I often think about bind is you have some sort of little language or way of talking about things. You have some way of getting the value out of this calculation, and then you feed it to the next step that uses a value to construct a new calculation. and then you return that new calculation waiting to happen. Now, that it doesn't always run that slowly is, because we do other things. But monads are really a good way of embedding and modeling evaluation strategies without having them specified in the underlying host interpreter, or how to add features.
So how can you explain what is happening in line 8 of that file?
We can take that offline maybe, and because I'm not necessarily the best person for explaining monads accessibly. But okay, so if we have this way of modeling functions, let's go back and think about what we were trying to do here. So this is a function. Well, okay, so this is with us without pushing the negation down. Right? This is a boring dual. I'm not really doing any translation here. Okay, so let's go. Oh, we were talking about sum. So now that we have CPS, so what would be the CPS? Let's take the CPS of. We want to understand how to refute A or B. Right? This is where we started. How do we say that? So this one we could say not of not A and not B, right? Does this make sense in terms of what we've discussed and sort of all we know? Now, if we expand that out, we get A to false, B to false, false, right? So this is for OR. Now, this is kind of interesting, and this is the CPS form of what is in linear logic called par. I'll talk about more of that tomorrow's session, but let's look at the CPS of AND. Because that gives us the right thing for talking about the right-hand side of a case, which is what I started with, is how do we say that? And now, once we have this vocabulary tomorrow, we can move a lot more aggressively. And even if we don't cover everything I want to cover, I hope you all feel comfortable asking about stuff all week. So we do the same not thing, and then we get not A or not B false. Let's just write that out a little bit more explicitly. We can do an either of A to false, B to false. This is exactly the thing you want to do a case on an either, right? You need to have, so it's like the dual, this is the dual for sums. Well, it's the dual for AND, because you have to be able to handle either scenario. So it's still a conjunction, but it's a conjunction for the negative, the consumer rather than producer position. And so this is a choice between two things, A, B. It's a negative conjunction. And you can use choice to talk about the, so choice A and B, the limit is the eliminator case thingy for A or B. When you want to talk about the right-hand side of the case, go with choice. You're only going to run one of them, which is very linear logic. But you need to be able to handle each scenario. So Does this sort of make sense as a starting taste of sort of thinking? The CPS of OR, if you...
2 more minutes.
Okay, you're really cool too. And the CPS of OR gives you par. This I'm doing the double negation to sort of help give the translation and meanings here. The idea is, another way of doing, a choice is basically a sort of a linear record where you can only get one field and then nothing else. Which means you can sort of define, as long as you have anonymous choice or linear logical records, a first-class notion of the right-hand side of a case expression, which is really cool. How do you talk about first-class matching on things? That's a choice. You have to actually have a data type that lets you talk about that. And how you actually operationalize these. Okay, so it would actually be choice not A, choice not B, because you have to actually have both. You just don't know which one you'll need until you do this case. Sorry for the typo. That would have been very confusing, I agree. Now, if you want to refute or disprove an OR, you have to sort of, so choice lets you refute an OR, but it itself is dual to AND. If you want to refute an AND, you need the dual of OR. And there's a more cogent one in that Michael Schulman paper I mentioned at the start. So another way you can get this funny other thing is you say not A, you have a proof construct that basically winds up being choice of not B implies B or not B implies A. And this is par A conjugate. And that lets you sort of recover the law of the excluded middle, which is A or not A is true in classical logic. It lets you talk about mutually exclusive properties, which is what you want if you want to say A and B is a contradiction. You want to be able to provide a proof that says, if this property is true, that one can't be true. Or, which is sort of a much more precise version that is still deducible if just A or B on its own in isolation is false. And I think that's it for today. I didn't cover as much as I would have liked, but I hope everyone got like 1 or 2 cool ideas about logic out of this. And I'm happy to answer any questions whenever. Were you happy you chose this section for the first day?
Yeah, yes.
Excellent.
Was that the title of this Mike Schulman paper?
If you just Google linear logic and Mike Schulman, you should find it. If not, I can email it to you.
Yeah, thanks.
And if there's anything and so it doesn't really get into sort of the further generalizations. Like, I think we can go eat food now, guys.
No, there's a break now.
Oh.
Coffee and food will be at 1 a.m. here.
Wait, but isn't this the second session? What? There's a third
Yeah,
session?
there will be one more talk here for an hour, and after that there will be a lunch.
Who's giving the next talk?
Lawrence.
Who's he?
He's there,
Oh.
smoking.
Okay. But yeah, so another idea I didn't really get to is it's useful, and this is what sort of pushes things into data types, is how do we talk about a bool signed by Bob? Once you start having this linear logical vocabulary, and all 4 connectives let you talk about all sorts of different choice and exclusivity and other relationships, and you add sort of like being able to say Bob said this, which might be it has the serialized version of a value validates against someone's public key signature thing. You start to be able to talk about identity and ownership really nicely. and you're not trapped here.
Thanks.
Thank you. Want some coffee?
Maybe. Did you enjoy this?
Yeah.
Did you get one or two cool ideas out of it?
Yeah.
Did I pace it correctly? I was worried. I think I moved at the right pace, maybe.
I'm really before about this and
Now it sounds interesting.
Najgorsze się skończyło już, czy jeszcze nie?